Hello everyone, I am Bhumika Linkayat and today I am going to present on the topic Supervised Learning Workflow from Data to Prediction. In this presentation, I will explain the step-by-step process of how supervised learning works, starting from collecting data, cleaning it, training models and finally making predictions. So, Introduction to Supervised Learning. So, what is supervised learning? So, supervised learning is a type of machine learning. It means that we train a model using past data when both input and correct output are already available. And it uses label data. So, for example, we have student marks input and grades output. The model learns the relationship between them. So, its goal is to predict outcomes for unseen data. After training, the model can predict grades for a new student. For example, spam detection emails predicting if a loan will be approved or estimating house prices. And another overview. So first is data collection. So here we collect raw data from different sources. Second is data pre-processing. Here we clean the data to remove errors. Feature engineering and selection. Here we choose the most useful inputs. And fourth is splitting data. Here we divide it into training and testing sets. Fifth is model selection and training. Here we pick an algorithm and train it. Sixth is model evaluation. Here we measure how well the model performs. Seventh is prediction and deployment. Here we use the model for real world predictions. So, the step 1, data collection. So here we gather relevant and high quality data. The first step is to collect data that matches the problem. For example, for predicting house prices, we need details about houses. The sources are databases, CSV files, APIs, web scraping, and sensors. Data can come from company databases, downloadable datasets, live APIs, websites, or physical sensors. For example, housing datasets feature like location, number of rooms, and houses size will help in predicting the price. So now step 2 is data pre-processing. So here we handle missing values. If some data points are missing, we find or fill them with mean, medium or remove them. Okay, remove duplicates and outliers. Duplicates can bias results and outliers where extreme values can confuse the model. Then normalize scale data. Some features like salary, in thousands and age in years are on different scales, so we bring them to the same level and convert categorical data into numerics. So for example, male and female can be encoded as 0 and 1 since models understand numbers better. Okay? So step 3 is feature engineering. So select important features. So not all columns are useful. For example, in loan approval, applicant salary is important but their favorite color is not. Next, create new meaningful features. So sometimes combining existing features gives better results. For example, total income is equals to applicant income plus co-applicant income. So okay, reduce dimensionality. If dataset has too many features, we use models like PCA to reduce them and make the model faster and simpler. So the fourth step is fitting the data. Here there is training sets. So usually 80% of the data is used for training the model. Next is testing sets. So remaining 20% is used to check performance. And why split? So that we don't test the model on the same data it has already seen. This ensures fairness and checks real performance. And the fifth step is model selection and training. So choose algorithm based on problem type. If it's classification problem like yes, no, spam or not spam, we can use logistic regression, decision trees, random forest or SVM. If it's regression problem predicting numbers like house price, we can use linear regression, rates, lasso or XGBoost. Then train model using training data. Training means the model learns patterns and relationship between input and output. Okay? Then next step is model evaluation. A classification matrix accuracy tells how many predictions are correct. Precision tells how many predicts positive and actually correct. Recall tells how many actual positives the model was able to find. An F1 score balances precision and recall. Then regression metrics mean squared error shows how far predictions are from actual values. R squared tells how well the model explains variation in data. Then cross-validation, we divide the dataset into multiple parts and test on different sets to make sure the model is reliable. And the next step is prediction and deployment. So it's our last step, okay? So predict outcomes for new data. For example, predicting if a new email is spam or not. And next is deploy in apps. So model are integrated into real world systems like mobile apps, websites or APIs. So they can be used by anyone. So now the advantages. So it is easy to understand and implement. Most supervised algorithms are beginner friendly. So it's easy to understand. Next is high accuracy with enough label data. If we have good quality data, the model performs very well. Then wide applications in industry used in finance, marketing, medical and diagnosis, etc. And now the limitations are requires large label datasets. Without enough data, the model cannot learn properly. So next is time consuming data labeling. Labeling data manually is costly and slow. And next is can overfit if not properly tuned. If a model memorizes training data instead of learning patterns, it performs badly on new data. Okay, and now what the conclusion we get is we start with the data and end with predictions. We begin by collecting data and end by making useful predictions. Then useful for classification and regression problems. Then both yes or no type problems and numerical prediction problems are solved. Then important for real world applications, the supervised learning powers spam filters, recommendation systems, fraud detection and many more. Then the reference I have mentioned over here, so you can go through that. Thank you.